Hey, welcome back. Now we are going to look at part 2 of this video in lesson 4 of the Great Discovery. And we're going to be looking now, doing some backtracking here. Sorry about that. We're going to be looking at multiplication and division. Multiplication and division is different from addition and subtraction because your powers of 10 do not need to be matching. Because we're going to use our exponent properties, and since our base of 10 is the same in all numbers of scientific notation, our exponents are going to be added if it's a multiplication problem and subtracted if it's a division problem. So in this case, it's usually better to keep the numbers in scientific notation if they're already there. So I am going to pull out, using the commutative property, my decimal numbers, my 3.4 and my 2.6. And again, I apologize for my face blocking it, but we get 8.84. And then I'm going to add the exponent powers of -5 and 3 to get a -2. And that is our final answer. It's already in proper form. If I were to put it into standard form, that works as well. I multiply and then I convert it back in to scientific notation. Lots of ways to do math. You're going to take the one that works best for your brain. All right, now we've got a division problem, but what we also have is, again, one number in scientific notation and one number in standard form. Either way will work, and I'm going to show them both. So if we start with standard form, we've got a positive power of 9, so that's going to be a very large number. Divide that by our 150,000. I can use my powers of 10 to cancel out matching zeros on the numerator and denominator, which gives me a smaller number to put into my calculator. Then I'm going to go ahead and convert that into scientific notation, moving my decimal place 4 points to be 2.4 times 10 to the 4th. If I wanted to instead convert them both into scientific notation, I'm just going to keep the proper scientific notation, and it's blocked out, but that would be to the power 10 to the power of 5. Because, again, with our division rules, I'm going to divide my decimals, my coefficients, as normal, and I'm going to take my two exponents and subtract them. Here, I get my answer. It's already in proper scientific notation form, and so I'm done. All right, now this is a conversion problem. What this means is we have a rate. Think back to 7th grade. I have the speed of light is traveling at a certain number of meters or distance per a certain amount of time in seconds. And so that is our speed calculation, and we have a very fast speed. Of course, it's the speed of light. But I am given this number in meters per second. What I want to know is how much does it go in meters per hour? So what we're going to do is recognize our rates as fractions. So I'm looking to change seconds into hours. Well, I might know how many seconds are in an hour, but what I know is how many seconds are in a minute and how many minutes are in an hour. So this is going to be a multi-step fractions rate problem. But don't worry, it's okay. All right, so I've got 60 seconds in 1 minute and 60 minutes in 1 hour. Now, when you're setting up your problem, what you want to do is make sure that wherever you start your first problem, so I've got 3 times 10 to the 8th meters per second, I'm moving that second unit to the bottom, because now when I multiply my conversion factor, I want to make sure that I set up that fraction with seconds, the matching unit, opposite. So in my original problem, seconds was on the bottom. I want seconds to go away because I want to convert them. So I want to make sure that in my next rate, seconds is at the top. And then I need to continue because I actually want minutes to go away as well, and I want to convert those to hours. So my seconds cancel each other out, my minutes cancel each other out. Now I'm going to go ahead and take all of my numbers. So 3 times 60 times 60. I put all of those numbers together and multiply them because they're all on the top of the fraction. Then I'm going to add back in that times 10 to the 8th power and my unit of meters on top. On the bottom of my fraction in the denominator, my only numbers are 1 times 1, which is 1, and my only unit is hours. So I'm looking at this number, 10,800 times 10 to the 8th meters per 1 hour. But this is not proper scientific notation form. So I'm going to go ahead and move my decimal point from the end of that number until I have a number between 1 and 10. And then I've got to increase my exponents to match. And so now I have 1.08 times 10 to the 12th power meters per 1 hour. So that is your conversion factors. And if you have actually listened along to this and gotten here, go ahead and submit your formative with the information that you did watch the video and submit that picture with the last question in, and I will be around at the next class to give you some candy. All right. Thanks, everybody. Bye-bye.